Good day, everyone. My name is Olabi Adenio, and I welcome you to today's episode and today's live coding session. Sorry for that. I don't know. Please, can you confirm if you can hear me now?
Yes, we can hear you.
Okay. So, welcome to today's live coding session, and I hope you have been enjoying your Amoye internship. Um, to my people in Nigeria, I hope the election has not been an issue and it has been relatively peaceful so far. So, as stated in the announcement, today's live coding session will be about integrating Pytest with GitHub Actions. So, Pytest is a Python testing framework that is used to write unit and integration tests for um, programs that are developed with Python. So basically, there are ways to write automated testing in the sense that you don't want to keep testing every part of your code manually. You just want something. The essence of programming is to eradicate boredom actually and to eradicate repetitiveness, if that is correct. Repetition, exactly. So the when as a programmer, after taking a lot of time to write some piece of code, when you want to test it, you still now start having to test it one by one. It is something that is quite how do I put it? It's something that is quite boring as a developer. So the automated way to perform testing, and there are automated ways to perform testing where people can just test whatever it is they have automatically. So I will be sharing my screen now. Today we are going to be using GitHub, and this is also an extension of your current stage in the internship. I know people are currently in stage B, and you guys will be working on continuous integration and continuous development. So CI/CD, you guys already know, you guys should already be familiar with the concept of what CI/CD is trying to achieve, where you just want to make sure that at each stage of whatever it is you are doing, you have checks that make sure that everything is correct the way it is meant to be. So um, this is an integral part of CI/CD where you can use things like this to make sure that these are platforms that you can use to create those checks. You get those things that check for the integrity of the code and whatever it is that you're writing. So without further ado, I will share my screen now and I will walk us through the process. And I'll walk us through the process of creating a a GitHub action that uses Pytest to test code. So before I continue, can you guys help me confirm that you can see my screen?
Yes, we can.
Okay. So I will just head to my account on GitHub. Okay. So to do this, I will create a new repository. Okay, so I'll call the repository name, let me name it LCS2, as this is the second live coding session that we are going to be working on for this course. So I'll make it a public repository, none, and then create a repository. So you guys should be familiar with GitHub. I think it was one of the most important things, one of the things that was talked about for the previous stage, where you guys were introduced to DevOps and what it is. So GitHub is a popular tool that we use in GitHub, and it's something that is very, very versatile and widely used by teams. So there are two ways to create, it's actually just a way, but there are two basic ways for you to implement a GitHub Actions. So GitHub Actions just serve as a process that you complete. It serves as something that is done automatically, that you don't have to call it. You get, so you just give it things that, okay, these are events, because those stuff events. You just tell you that, okay, these are the events that will happen before you can occur. But it makes sure that as long as they're in that repository and as long as those events happen, the steps that you have decided to run, we always run. So that is what GitHub Action does for us. So it's a way for you to, so let's say you're working with a team, you're collaborating with a team. So when there's a like standard code base where everybody is working with together. So different people will have different things that they want to add to it. There will be the front-end designer and stuff, and different people that are working on different parts. So GitHub Actions gives you a centralized way of making sure that each person is contributing what can be what integrated into the entire code base. So as I was saying, there are two ways to do it. You can, but they basically do the same thing. One way you can do is that you can come to this action tabs here. So coming to this action tabs here, it will show you a list of actions that you have. As you see, get started with GitHub, skip this, set up a workflow for yourself. So there are some things called standard actions. You can see continuous integration. That's the other part of the term you are getting more familiar with, pages and all. So these are different. They call these quick starts that can help you. These are like actions that they have implemented already. So you don't need to go through the process of writing everything from the start. So you can just use this and deploy it. You can just take one of these action and they will give you the YAML file that you will work with. But that's not what we're going to. So you can just say, you see, you skip all this and you do what? You set up a workflow for yourself. So when you set up a workflow for yourself, when you click this button, it takes you to exactly. You see what it's showing you now. It's showing you that you want to create a new file. You see, you want to create a new file, and you're creating a new file in a directory called .github/workflows main.yaml. The other method that I was going to show you, if I cancel these changes now, if I cancel this, you see, and there's nothing here. So the other way that I'm going to show you is basically the same thing, so that one you don't have to specify all this yourself. So instead of going through actions, I will say I want to create a new file myself here. And after creating the new file, I will specify that I want it to be in .github/workflow/main.yml. YAML file. It's called YAML file. So this is basically the same thing, and they do the same stuff. So it should be workflows slash exactly. If you don't get these directories correct, it will not work, because it's specified that it has to be in .github in a folder that is called workflows, and then you have different YAML files. So this is the first step. So those are the two basic ways that you can just create a GitHub action file. So the other way, this way just is a way that most people, because I'm using the dashboard page of GitHub, but we know that mostly developers like to do it on their local systems using command prompt and all. So if you want to do this on your local system, like say you use your command line, because you can use Git on your command line. So when you use Git on the command line to create a new repository on your command line, then the easiest way for you to create an action, since you won't have is to just create a new file in Git directory on your local system. So that's that on how to create it. You can decide to name it any name. Sorry for that. Any name you name your file, the GitHub action will still recognize it as an actions file and it will be listening for what is it. So we'll now start defining everything that is needed in this. And everything I'm going to say here are things that you should have seen or things that you will still see in this stage, in your current stage in the internship, because there's a part where we specify on actions, GitHub actions basically, and what they can do and how powerful they are. And I think you should also have a follow-up lab or a follow-up lab. That's the word I'm just going to use. A follow-up lab that deals specifically on using Git actions. So your attendance to this live coding session is a plus because it gives you an head start and you are not totally lost when you start completing that. So as I'm going to start, the first thing I'll decide is name. So any word that you see that has I think this should be a colon. Exactly. Same is the one that has a comma underneath. So any word you see that has a colon beside it is called a keyword. And these are the keywords that GitHub understands. These are the keywords that GitHub can use to understand whatever it is that you have defined in your workflow. So when you put a keyword that GitHub does not understand, it calls you out and tells you that it doesn't understand this keyword. And there are keywords. Keywords take specific kind of things. You cannot give a keyword a parameter that is wrong. GitHub will also tell you that it is wrong. So the first keyword that I've used here is the name keyword that tells us the name of this test. So instead of just using test, I'm going to call them Pytest. Let's do that. So I'm going to name it this set of tests because you can have different series of tests. You can have your Pytest, you can have your tests that test for your CI, the continuous integration that uses Travis and all. You can, if you are using more than one language, you can have testing frameworks that are not for Python that can use the Java testing framework. So you can name those ones JTest. But the naming, as we all know, is just decided to you. So the name of the test is going to be Pytest. And then the next word I'm going to use is on. So on serves as what listens to the events. This is what listens to events. So on is where we define the kind of events that will make this set of tests run. If these events do not happen, this test will not run. You get, so you can define different events on GitHub actions, and all of them different events that are specified. You can't just define any event basically. So there are actions that can be performed on GitHub that are classified as events. And when you go to, there's a specified documentation for GitHub actions where you go to and you see the kind of events that you can specify. So, and for every keyword they are going to use, there's something called indenting. So YAML file is actually very, very key on indenting. Once you have an indentation break or you have unaligned indentation, your YAML file does not work. So for every keyword that you use where you want to define everything that belongs to that keyword, basically, you have to indent it under. People that have worked with codes like Python and other programming languages will know what we mean by indenting, because whenever you define a function, you have to indent it under. If not, it gives you an error that you have an unaligned indentation. So for each keyword, you ident every variable. Let's just use that abstract term now that belongs to that keyword. So I'm going to tell you that this is another key. It's called the workflow dispatch _dispatch. So what the workflow dispatch does is that it tells us, as I've said previously, it just tells us that this is when the workflow should be dispatched. So these are events. So this is the first event that we are going to specify here. The first event that we're going to specify is the workflow dispatch event, and it's going to anything I specify under this is going to tell us that okay, this is what should happen before this workflow can be dispatched. So I'm going to say that I want this workflow to dispatch when a pull request is made. You can have types of pull requests. I want it to happen when there's an opened pull request. I also want it to happen when there's a reopened pull requests. You get, so this is just me doing a basic example. There are many other methods that can be used for you to do this. You can decide to have a workflow dispatch that happens when a pull request is closed by someone on the team. You can have a workflow dispatch that happens when a pull request is edited, or when a push is made to the stuff. There are different types of workflow. You can also have a workflow that happens immediately a push is made to a specific branch. You get stuff like that, just that gives you more control over what the kind of action that you want them to perform. So I'm just going to do this as a basic step. You get, and for you to when you are working on yours, you have much more stuff to explore with, and then when you go to the official documentation, you can see the kind of things that you can do. So the next stage, okay, is the permissions of this workflow file. So I'm going to tell you the kind of permissions that you need, basically, because you might have workflows that want to make some edits in your GitHub. You might have workflows that want to like write something. There have been cases where GitHub actions have been used to make edits in the README file. I think you guys should notice that whenever in the previous stage that you completed, for your stage B, wherever it is, that when you submitted or when you completed the previous step, you see that there will be a green stuff that rolls, and when it's that when you refresh your README page, instead of being at the previous step, it goes to the next step automatically. So that's what GitHub Actions can do. It is GitHub Action that is able to allow us to make that automatic updates to the README file to go to that next step where you want. So permissions, I'm going to indent this under it, and I want it to be able to read. So I've provided the permissions that this workflow can read contents on this repository. So if you are going to write a workflow where things can be written, you also need to provide a write permissions and that. So that's that on that. And then I'm going to list the jobs. I'm just going to make sure that this is properly indented to not have an issue. Okay. Okay, I think it is now. So this is the job keywords. And the job keywords is where we start to list the things that we want to be done. You get it? We start to list, okay, these are what I need to perform this option. These are the materials that I need, these are the tools that I need, and this is what I want to be done. So that's the job keywords. And underneath the job keyword, I'm going to Pytest job. So you can have different kinds of jobs. You get, let's say you can have a job that first test. So let's say you have different tests, or there are different there are different folders, exactly, different spaces, different folders in that repository. So you might have a job that you can say the name of this folder. Let's say you have folder 1, 2, 3. You can say Pytest job folder 1, Pytest job folder 2, and stuff like that. So you can have different jobs. Just signify what the action that you want to be performed. As okay, we have specified that this workflow will dispatch. So if in the event that the workflow is dispatched, what are the jobs I'm going to perform? So that is what we list under the job. So you can list multiple jobs, and under this Pytest job, that signifies the name of the job. So under the Pytest job, I'm going to specify the first thing that we need, and that I need a what? I need a Ubuntu system, basically. So what this does is that it is telling you that this job is going to run using the Ubuntu latest OS. That's what it's just trying to say. If you need a Windows OS to run it, you can use Windows. If you need, there are different type of OS. There are not even OS per se. There are just different type of container and container images that might be needed for you to run whatever it is you need. So this just serves as the platform that you know that this is the platform that you can use to run your test. So you might have specific tasks. Let's say, for example, you are working on a specific OS, you are working for a specific task that you need another kind of image. So when you go to GitHub Action, GitHub also lists the the list of accepted images and supported images that you can use to perform your actions. And now it is time to start listing the steps that are going to be performed in this job. So it's basically just following the main flow of how almost anything is done in this life. So for you to perform a job, there are steps that you must do. So let's say it's just like a recipe basically to cook rice. There are steps that you must follow to cook rice. To bake a cake, there are steps you must follow basically. So for this job, so I first started from saying that okay, I'm going to have some jobs. This is the first job that I'm going to, okay, just to follow convention. Let me change this to Pytest job. Exactly. And then for this job, it's going to have its own steps. So now I'm going to start listing the steps for this job, and for each of the job, okay. So this is the name. So each job, for each of the steps, this is not required. You get, these are things that they are not required. You can just decide to use this, or you can decide to use other keywords. Well, I like naming my job because it makes me know, it allows me to be able to know where I am. You get, so in the event that an action fail or a step fails, it makes me it notifies me, and it makes it easier for me to locate where the action failed, so I can locate it in the YAML file and then correspond with the part that failed. So basically, one of the first parts for almost um any GitHub actions that you write is that you always want to check out, because based on what you're working with, because when the action is created, you get the action is when the action is created, sorry, when the workflow is dispatched, it is actually, you are defining this now. For example, you are defining this on the main, you get, on the main branch of your repository. And the idea is that people are going to be creating other branches for them to contribute. So those other branches that they are creating, for you to be able to access whatever it is on those branches, you have to do what? Checkouts into that branch, basically. So people that are very familiar with Git would have an idea of what it is that I'm saying, because it is a popular stuff. So they have to check out into that what? You have to check out into that branch that is using that. So the first step that you see in almost any job they are performing in an action is what? Is to check out the code. And to check out the code, we don't do it ourselves. So GitHub actions have what they know that there are some things that are very common. It's just like when we use modules and all for our code. These steps are very common and they will be used repetitively. So GitHub have provided ways for you to just call. So you just call actions and say that you want to use what? Checkout from GitHub actions, CHECKOUT. So there are different versions of checkouts. I'm using version 3, the latest version of checkout. So GitHub knows that checking out is a step that will almost be always needed. So it has provided the way for us to what? Use GitHub checkout. So whenever you go to the GitHub documentation, you will see a list of already provided actions that one can call when defining a YAML file like this. So that's my first step. Then the next step, let me just give some space here for to make it more beautiful. So the next step that I'm going to do is that I'm going to what? Set up Python. So I'm going to set up Python for my actions. Why? Because I'm using Pytest apparently, or obviously is the correct word. So I'm using Pytest obviously, and Pytest only works for Python. So I need a Python engine or a Python environment for it to work. It's just like you going to a system that does not have Python installed, and then you want to run a Python program. It's definitely not going to work. So these steps that I'm listing here are just steps that are listed by GitHub on how to set up Python in your action environment. So when you just go to, it's just like you reading the documentation of any language. So there are popular things that you might want to do that have been done before, or there will just be guides on how to do it. So this name is just me naming it anything, and I'm going to use what? Actions. just as we use checkouts, I'm going to use setup Python actions. So setup Python at version 4. So it will not make sense for you to have to keep typing a set of code every time you want to create an actions you get that uses Python. So it's just the way it's just norms for you for there to be a method that is centralized where anyone that wants to call up or set up Python on user action can just do it. So okay, this is not done yet. With this, so I'm going to say that I want to use the Python version 3, sorry, 410. So yeah, you can specify any Python version. GitHub also makes it, I think with this new version 4, they make it possible for you to specify multiple Python versions, and then for each other steps, you can start to use those multiple Python versions for different kind of tests, because you know that sometimes we have compatibility issues. So let's say when the code was created, basically, when the app, the repository was started, we were using Python 3.8. And then over time it have been maintaining over the years, and then when you now after 2 years Python 3.10 has come out now, and there are people that are making edits to the code using that version. So there might be issue of cross compatibility and stuff like that. So GitHub, this that feature is also a handy way for you to handle issues like that, where you can easily test for actions that were created with the new version, and then make sure that the older ones too are still working. And then the next part is to what? Install dependencies, or just let me say libraries. So you need to install the libraries that you need. This is a very important step when you are testing things that are using libraries. You are testing code that are using libraries that does not come with Python. Python has its own bundled libraries that come with every installation. But then there are also times that you have to do a pip install for libraries that you need that do not come bundled with Python. So for you to also be able to run tests for those types of stuff, you need to make sure that your Python environment on your GitHub Actions also has those modules installed. So with this one, I'm just going to run. Okay. So, sorry. So with this one now, so this line just tells it that the stuff is starting from the next line. So it's just like a marker for each say that go to the next line to run whatever is there. So one is just like you typing something on your command line, or typing it on admin on your DOS for people that use Mac. So for people that use Windows, just like you going to command prompt or going to PowerShell and then typing this command, and it should be very what I'm typing now for people that are accustomed to Python should not be new, because it is something that you must have used at one stage or the other. So I'm watching Python pip install to upgrade the pip first, and I'm then going to pip install Pytest. So Pytest, though it is the one of the most popular and official Python framework, it does not come bundled in with what Python program. So we need to make sure that we install Pytest into our environment, and we need to make sure that we install Pytest into our environment and make sure that it is available for us to perform the testing. So now that we have installed Python and Pytest, the next thing to do is to just run the test basically. So to do that, that will be my last step for this action. Let me come here, put a space. The name is run Pytest, Pytest, and I'm going to do what? I'm going to run Pytest. To just show you, okay, so Pytest. So what you just do is just it run Pytest. The easiest way to run Pytest is to just call Pytest on your command line in a repository that has the Pytest folder. So I'm going to just, before I even start our own action, I'm just going to show you some built-in action of GitHub, like some built-in actions that will always run, so for you to know how it works. So I'm going to intentionally include an error in this file, And to do that, I think let me do something like this. Okay, exactly. Now this, with this now, I've included an error in this one, because what have I done? Whenever you, under steps, whenever you give it an hyphen like this, it means you are defining a new step basically. So what I'm doing now is that for this step, I just defined a step that has only name. You get, I did not give it anybody, and then I defined the step that has run. You get, so this will give me an error that every step must use what, uses or run or with, something like that. So what this does is that I've introduced an error into this file intentionally so that you can see what GitHub Actions does actually. So I'm just going to comment this. I don't have to comment because time is going already. All right, so if I come down to this actions page, you can see this. This is a failure. Now, failure. And this action is not an action that is for me. You get this now. This now shows you what actions is. So, and immediately this action has failed, I'm automatically updated on my Gmail, because my Gmail is attached to this GitHub account, that a specific action has failed on so and so repository. So you can see that, okay, the error that I even intended to, the error that I intended to cause the error is not the error. You can see the error that we have here is that what, workload dispatch. I forgot to include the F, but I think now you can see the beauty of GitHub Actions. You see that immediately I committed the file, there was an error. Once you come to Actions, it tells you immediately that, oh, there's an error, and that is what is happening. So I'm just now going to go back there and edit my unintended error and my intended error because it has actually shown us what I want us to see. So I'm going to come in, I'm going to add an F. Okay, so you have not chosen the fact that I want to edit this file. So the network should be faster. Okay, so yeah, did I mean workflow dispatch? I did. Why did you not tell me before? So yeah, this is workflow dispatch, and yes, I'm going to start it. Oh, I'm sorry, I have not edited my own unintended error, not yet. Okay, so come down here, and I'm going to just remove this, and then okay. So now start commit my changes, and if we go to actions now, hopefully we shouldn't see any error. Voila, you can see that we have only, if the edit that we made had an issue also, it will come here and then say that the commit blah 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 is an error. So since there's no error in this commit, we have automatically defined our workflow. And you can see you can see that in all our workflows, we are now have a workflow called Pytest. And that was the name that we named our what. You see, Pytest, this workflow has a workflow dispatch trigger, it gets. So our Pytest is in main.yam basically. So we are done creating our workflow file. So the next thing now is to see how it works. So there are numerous ways on how we are going to do this, but I won't go into much. I'm just going to follow standard procedure. The standard procedure is that after you create a workflow, you are the owner of the code base, and you are the one that knows that these are the tests that are meant to be run. You get. So I'm just going to add a Python file that runs the test basically. So I'm going to add a Python file that runs the tests. Okay, so I'm going to name it tests.py, and I'm going to define, I think, let me just define two tests in it. So the test is going to be in Python code because, as you already know, yes, def function x, okay, return x plus 1. So people that understand Python code will understand what it is that I've just done there. I defined a function called func, I'm going to define another function called func2 that takes one argument x and it returns x plus 1. This one is going to return what? X plus 2. Okay, now I need to define the test. So I'm going to define tests func. Okay. So when I'm defining test func, I'm going to make sure that our assert. So assert is the keyword that I use to ensure that whatever it is you have is correct. Assert that func of 3 is equals to what? This will be equals to 4, yeah? Because we said when you call func on x, return x plus 1. So if I call func on 3 and I say 3 plus 1, it should be 4, yes. So the next one is def as do this linking problem safe. Okay, I hope this is good. Def tests func. I'm going to call it test func2. Okay, and assert func2 of 3 is equals 5. So I've defined two functions here, func1 and func2 basically. And what func1 and func2 does is that for func1, it returns x plus 1, func2, it returns x plus 2. You can name these any, I just decided to name them that because that's what is used in Pytest official documentation actually. And dev test function, blah, blah, blah. So you can just name all of these. Pytest knows how to work his way to know all of those. So I'm going to commit this automatically. And I hope I don't have a indentation issue with what I wrote there actually, because the indentation is giving me concerns. But yeah, we are good to go. And with this now, we now have two tests just to show us this. Okay, we come to actions. It won't run. Why did it not run? It did not run because the what makes that workflow dispatch is a pull request that has been made. So we have to make a pull request for that to run. But you can also run your workflow. You can run your workflow. How do I put it now? You can run your workflow manually. You see, if I say run this workflow, I'm just going to run it to get. So I'm going to run this workflow for it to let us just see that it passes. And then we are now going to create pull requests with edits to the code. And we see, okay, did that one? Yes. Okay, you can see that this is running now. So let us go into it. And wow, it has failed. So let us see why it failed. If it is an issue with the YAML file or if it is an issue with the code that I wrote. Install libraries, I see. Python command not found. What an error. So in my YAML file, I included M in Python actually, and it should not be Python. It should not be Python, it should be Python. So let's head back to our YAML file and edit this. That was a mistake. So these are issues that as developers, people will face once in a while because they always have typos and all that causes issues like that. So this is okay, sorry, I've not chosen the option to edit the file. I'm actually used to doing everything on my local system. So I'm just doing it to make it easy for you guys. And okay, so Python version, blah, blah, blah. So this is Python mpip install. Let me just glance through to see if I have any error. I don't think I should have any error. So start commit changes, blah, blah, blah. Okay. That has been done successfully, actions, and then let me manually run the workflow again for the second time. And hopefully this time I don't have an error, or if I do have an error, it should be from the Python file that I wrote. It was successfully requested. Thank you very much. All workflows. Okay, it is running now in progress. It has failed again. So I must see why it failed. What? I'm very sorry for this. So is my so this is the other option. Upgrade. It should be upgrade. Am I typing too fast for what? So I'm going to head back to that, and sorry, we should have passed this stage, but it's part of the issues that we face as developers. So it should not be something new to most of us, and it can be quite costly actually. Imagine it's a case where you are using infrastructure to build, and that is why we are having things like this to make sure that changes like this are not made to make sure that changes like this are not made to your code that can cause a bigger issue later on. With Pytest, we are able to, sorry, with GitHub Actions, we are able to figure out those errors immediately and make sure that they are fixed before um, our code goes live. So this should be upgrade PIP pip install Pytest run Pytest INSTALL. I hope that's still the correct pronunciation, sorry, spelling for install. So let's do this now, and hopefully we should have a green arrow or a green marker as it is normally called on our test. So let us do this and let's dispatch our workflow again. Okay. Well, we are past the install stage. I see. No test one. Okay, so this is an issue with my Python code for the Pytest because LCS, so because the test should run automatically. The Pytest should figure out the Pytest file automatically. So let me go back to it and see what is happening. Okay, I'm coming. Let me just let me edit this file and change the name. I think is the name that will cause an issue because the naming convention for Pytest is that it should test something. So let me name this test underscore main dot py and then save this. Okay, so I'll come back here and run this manually. I'm actually very sad at the amount of X I'm saying here. So let's run the workflow now and hopefully we have a great marker first and then we just create a branch. And after creating a branch, we make a pull request and see it dispatched by itself. Okay, Pytest job is going through. Exactly. So I think everything has gone through successfully and we should see a green check this time around. Let me just come back to actions since that page is taken. Exactly. Finally, so we now have a green marker to show that this shows us two things. Number one, our tests are running correctly and our workflow is being passed. So we have gone through the first stage of, we have gone through two stages now. We have created the workflow file. Sorry, we have created the workflow file that uses Pytest, and we have also created an automated Python test in our repository that can be run automatically. So to now showcase the third thing, which is also going to be the last thing, I'm now going to create a new branch and call this branch dev. So um, you can see now that I'm in the branch called dev, and I'm going to make some edits into this branch. So I'm going to make some edits into this branch, and then I'm actually going to create two branches, another branch apart from this one. For this branch, I'm going to edit this file. I'm going to do what? I'm going to add codes that will what? Okay, so I have the file now. So I'm just going to add two more successful tests to this one. Def from 3x return x plus 3. So I'm just going to just show us different ways that this could be done. So I'm now going to also write the tests. One, two. Def test func 3. Okay. And assert that func 3 of 3 should be equals to 6. So that is still correct. You get. So the people can make different edits, but it's not actually cool to edit the test file actually, because the way we use Pytest is that we don't actually like the testing files should not be edited. I'm just doing this to showcase, you get, to just use this as a demo. In practice, the test files are not edited by people that want to make development. They just edit other parts of the code base, which are then tested with what tests that you have made previously already. So I'm just doing this just to showcase what we can do. So I'm going to make this successful, and then what, commit the change. So for the other one, I'm going to add a wrong assert, I think, or I'm just going to edit the function to not actually correspond to what is meant to be there. So let me go back to the main, and let me create another branch. Let me call this dev2. I'm going to create the branch called dev2. So in the branch called dev2, we have our main.py already, and you can see that the change that we made in the dev branch is not here. So that is something that you guys should also be familiar with a little bit using GitHub. So we create different branches. That's what I'm saying, that different people are making what different edits to the code. So one person can be making an edit to main, when another person is also making another edit to main. But we just use that central testing to make sure that each edit being made by people is what is true. So let me just change this from being x plus equals 1 to x plus 3. And that's the only change I'm going to make, to just allow the test to fail. So you can see how it works. So now with those two done, I'm going to create a pull request for both of those branches. So let me just go to the LCS2. You see, exactly, it has told me that dev has. So I'm going to compare this and create a pull request. Yep, create a pull request. So that is for the first branch, the dev branch. And you will see that immediately we created a pull request, some checks having been completed here. You see Pytest is working already. So we have this job that you see, I did not have to go to actions to what, go and trigger it manually. And you can see that now the test, it has been what, verified. Because why? it has what? It should pop up, it has passed all tests. But commission signature, you see, all checks are successfully be passed and blah, blah, blah. So let me just say that it should show me the checks. You can see that it is only one check. But this our check, we told you that anytime a pull request is created, it should run. And immediately we created a pull request using the dev branch. The workflow was run immediately. And with this, I want us to see the details of what was done. You see, so all the steps that we defined, we first set up a job, blah blah blah, current running version. So this is where we set up the job to use runner. We checked out the code. So we checked out from being in main, we came into the what? The branch. So after coming into the branch, we then set up Python as usual, and then we want Pytest. Pytest is where it is gone. And you can see that you can see 3 tests passed in blah 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 seconds. So that is what Pytest gets. So you don't there are also different kind of actions that can be made. So you do not have to come here to come and start saying that ensure that this is this. No, we did that with a programming language that you're familiar and confident with, and then just integrated it with what? GitHub actions. So I'm going to call the other pull request now, and we can see that this one now should give us an error. Compare and pull request. Okay, now create the pull request. So now this is what some checks are still a queue. It is running, it is running, it is running. Some checks haven't been completed, and we should see an X soon. Exactly. You see that the checks are failed. So if we go to the details, you can see that it's still the same Pytest job. Why? Because we have told you that anytime a pull request is made, it should run. And you can see that now we have a test failure from Pytest. In the test main.py, you said we are testing the function func, and we are saying function should tell us that it should assert that it is 4. Meanwhile, we have said what? Anytime we pass function 3, it should add 3. So 6 is not equal to what? 4. And that is why this space has failed. So that is basically what we can do for pull request. And you know that I also specified that in the YAML file, I specified that what we can, when a pull request is closed. So I'm just going to do something now to just like I'm just going to do something now to change both of them in a way. Now you can see that update test main.py blah 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 is the one that you can see that the pull request from dev into main is the one that passed, and the pull request from dev2 is the one that failed. So I'm just going to do like a quick switch. I hope time permits me because this is 12:53 already, but it shouldn't take much time. So I'm just going to do a quick switch to make now dev is the one that is going to fail and dev2 is the one that is going to pass. So let me come here and then let me make this fail by saying that assert. Let me edit this file. So assert this is equals to 9. So with this now, I'm sure that this is going to fail. I'm just going to commit my changes into the dev branch. Okay, so now let me go to the dev2 branch also, and I will change that to 6 from 4. So edit this file. And change this to 6 instead of 4. And I'm going to commit my changes. All right, so that should do it. But if we go back to actions, you see that it has not changed yet. Sorry, pull request. But because we have made edits to the pull request now, the X and this is from dev2. So there's no X, there's no mark. If we go to actions also, we can see that the actions that will happen, you see, this one is just the last 2 actions. The actions did not happen again. Why? Because we did not specify that our workflow will dispatch if you push. to those branches. What we did was that our workflow will only dispatch if there's a what? A pull request, or if the pull request is reopened. So what I will do is that if you can remember correctly, this was the one that failed because dev2 to main failed. So what I'm going to do is I'm going to go into this pull request now, and I will close it and reopen it. Oh, thank you very much. You can see that this was it failed previously with this action, with this commit, and okay, I thought it had a pop-up. So what I'm going to come here is just I'm going to close this pull request, successfully closed, and then I'm going to reopen this pull request. And with this, we should see that our workflow will start again. And when our workflow starts again, exactly, you can see that our workflow has started again. And this time, it should say that what all checks have been passed. You can see successfully all checks have been passed. So with this now, we have been able to what? So this is just means knowing that when both you as the owner, as the maintainer and the owner of the repository, and your team, your team members that are working with can in real time see that the code that they have made, or the pull request they have made, the code they have contributed is failing. They can what immediately start to make amends and correct them. So with this now, we have been able to successfully correct a mistake that was made in our previous pull request, and now our new pull request, after closing it and reopening it, it is what it has passed. So that is for the pull request 2. Now I'm going to go for the pull request that's what passed the previous time around, and you can see that it passed the previous time around. So I'm just going to come here, close this pull request. The reason I have to close it and reopen it is why? Because I specified in my workflow file that you should only dispatch when the pull request is what? Opened or reopened. If I had specified that anytime a push is made into a pull request, then I wouldn't have had to do this. We get a push that we made when we edited those files should have made the workflow process starts immediately. So now you can see that our checks are being run, and this time we should have a failed check underneath here as compared to when it passed before. So with this now, imagine this is a code in a code base where you are working officially. A developer that contributed this is able to know that, oh, I have an error in my code. Is able to go into actions, get the details of the test that failed, and immediately that developer is able to make amends and then recreate the pull request, or we get or make pushes again and make sure that the actions or the test pass before he or she is satisfied that I have made contribution to the code. And with that, we have come to the end of today's live coaching session, and I hope I've been able to showcase to you guys the action of using GitHub Actions, how wonderful they are, and how we can integrate them with Pytest for code bases that use Python. This can also be done for any other language, basically, as long as you have an idea of the testing framework that you want to use or the kind of test that you want to run. It doesn't even have to be a testing framework. It can just be a file that you have written in your own, with your own idea or something. It can just be a file that you have written, a series of checks that you wrote with a programming language using your own logic, and then you just run that file. And if the file runs successfully, your action also runs successfully. Else, the action fails. So I wish you guys a wonderful week ahead, and I hope you guys are enjoying your stage at the current internship. Do have a wonderful week. Thank you.